Thank you, Doc. Um, my name is Rich. I'm living proof you don't need a lot of money to be rich. Every now and then I'll go a few days without taking a shower just so I can be filthy rich. So it works out. You guys down here in the front row, you may want to back up because today I'm filthy stinking rich. So anyway, this is my ministry, Theories of Creation. And my own ministry can be found on YouTube at Theories of Creation. And soon, within a week or two, I'll have a website, theoriesofcreation.com. What is Theories of Creation Ministry? Theories of Creation is, why isn't my mouse working? There it goes. Is a unique look into the physical laws of the universe and what they tell us about how it originated. Questions about what we observe, why it exists, and why self-existence is not a logical explanation. Can an infinite universe spontaneously appear from an absolute vacuum into the thriving, energized existence we observe today? Is there scientific evidence for a supreme being? Can science point towards God? This message is entitled, Why the Universe Cannot Create Itself. I hope this lesson to teach you that physics will not allow the universe to create itself, and physics shows that it is necessary for something to put it into existence. I believe because there is such a thing as motion, the universe was created. This first part is on the Big Bang Theory and why it is not possible. If we take a deep dive into physics, it will show you that it is impossible for the universe to expand out of a singularity. The only explanation is that space-time, energy, matter, and gravity were placed into motion by an external force. Physics shows that Genesis 1:1 is the only explanation. It says, in the beginning, God created the heaven. It does not say that God made the singularity and then the heaven. So what is the Big Bang Theory? The Big Bang Theory stands as the most widely accepted explanation for the origin of the universe. According to this theory, the universe began as an infinitely small, hot, and dense point which rapidly expanded and continued to stretch over 13.7 billion years. This initial period of rapid inflation set the stage for the vast and still growing cosmos we observe today. So how did they get that theory? In a nutshell, the universe is observed to be expanding. Scientists look at the stars and observe that they are moving away. They follow that motion backwards in time and assume it all came from a single point in space. Here's a diagram showing how they think everything was put together over a long period of time. On the left, you will see that everything started from one single spot and then expanded outwards, then gradually became the universe we observe today. Here's another diagram. According to this model, quantum fluctuations initiated the rapid expansion. What are quantum fluctuations? Quantum fluctuations are temporary, random changes in energy at a specific point in space arising from the fundamental uncertainty in quantum mechanics, according to their wiki page. This means that even in seemingly empty space, particles can briefly pop into existence and then disappear due to energy fluctuations. That first part, arising from fundamental uncertainty in quantum mechanics, this is the most intellectual explanation for we don't know how it happens that I've ever heard. Do quantum fluctuations prove that the universe can create itself? Let's ask the question. Seems like a pretty good assumption. If we can observe energy is coming into existence, then we can assume the universe can create itself. My opinion, no. It is not proof. Why? Because it is happening in an already existing universe. The universe is here. Quantum fluctuations are one of the many phenomena within space-time. How can quantum fluctuations happen if the universe doesn't exist yet? It does not prove that the universe can create itself. Going back to the Big Bang Theory, the universe began as an infinitely small, hot, and dense point. In other words, it started out as a singularity. This is an artist's representation of a black hole. A black hole is the only somewhat observable singularity in the universe. I say somewhat observable because we cannot see what's inside it. We can only see the light that is bending around it. This is the first picture ever taken of a black hole. Why is it called a black hole? It's assumed it is a very, very dense body with so much matter, light cannot escape it. If light cannot escape it, we cannot observe what's inside. The way our eyes work is they pick up on the light that is being reflected off of matter, and then our brain registers the information and we see the world around us. Light cannot escape a black hole for us to see, then we cannot obviously see inside it. Stephen Hawking once said, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. It is why the universe exists. It is why we exist. It is not necessary to invoke God to light the blue touch paper to set the universe going. That's a pretty bold statement. So I asked Google while researching the topic, why does gravity exist? Gravity exists because of the fundamental property of mass bending space-time. This curvature of space-time is what we perceive as the force of gravity, causing objects with mass to be attracted to one another. While we know what gravity does and know how it behaves, the fundamental why it exists remains a deep mystery in physics. It was basically just a copy-paste right after the search. So what is gravity? No one knows for sure. Like my friend Dr. Kent Hovind says, give me a jar of gravity and paint it red. However, we know what it does. Gravity is something that pulls matter and energy toward each other while wrapping the fabric of space-time in the process, while warping the fabric of space-time in the process, excuse me. The best guess is that gravity is space-time trying to return to its normal position. It acts like water returning to the center of a pool after you displace it with a beach ball. So if you took a beach ball and dunked it into a small pool, you will displace the water out to the side. And gravity is kind of like the water wanting to return back to its original position. On top of that, if you add in the effects of attracting magnetism, and you get the understanding of how it works. Gravity is attracted by the inverse square law. The closer the objects get together, the stronger the attracting force is between them. In simplest terms, well, gravity is a force. In simplest terms, force is a reaction. Something had to initiate the force to take place. That initiation is matter. How can any force create the thing that is needed to exist to cause itself to happen? That's like saying I can whistle without having lungs to blow air through my lips. Nowhere in what we observe do we see that gravity or the law of gravity can create anything. The first law of thermodynamics says that energy can't be created or destroyed. The same is true for matter, gravity, space, and time. This seems like one of those prove me wrong theories, because you can't go back in time to observe the introduction of the universe. What we can observe is that gravity cannot exist independently, because all gravity we can measure is based on the overall mass of the body it is pulling towards. So back in 2011, NASA launched the GRAIL mission, Gravity Recovery and Interior Laboratory. The mission involved 2 spacecraft, Ebb and Flow, flying in tandem around the moon. By precisely measuring the distance between these 2 satellites, scientists could detect subtle variations in the moon's gravitational pull. By doing this, NASA figured out the variations in the moon's gravity, By doing this, NASA figured out that variations in the moon's gravity field are caused by differences in the density of materials both on and beneath its surface. As the satellites orbit around the moon, if the leading one would accelerate on its own away from the tailing satellite, it meant that it traveled over a denser part of the moon and they were able to map it. This is one way NASA proved that gravity is based on the density or overall mass of a planetary body. By the way, you are made of mass, and therefore you generate your own gravitational field. Some more than others, but that's a different issue altogether. You can't see your effects here on Earth but because the gravity of the Earth is too strong. If you went far out into space, far enough from any planetary mass where you were barely affected by any external gravitational force, and released a marble at arm's length, it would slowly drift towards you because of your gravitational attraction. Ebb and flow showed us that gravity is part of a symbiotic relationship to matter. Neither matter or gravity can exist independent of one another. Gravity cannot create matter, space, or time. What you have is just a big chicken and the egg problem. What came first, the chicken or the egg? What came first, the gravity to make the matter or the matter to make the gravity? Both had to come into existence at the exact same time. The singularity said to exist at the beginning of the universe cannot place itself into existence because of gravity. I asked a physics major, where did the matter come from to form the singularity? He said they didn't know. The first law of thermodynamics states that energy can neither be created or destroyed. The same is true for matter, gravity, and space. If that law is true, which it is, how did it get here? This question brings up the theory that maybe the universe might be infinite. I don't think that's possible because the universe is in motion. Everything from the largest galaxy down to the smallest molecule. Believe it or not, if you pick up a stone or look at this table, it seems solid to us. If you go down to the molecular level, you will see that it is in motion itself. The universe can't go into motion by itself. More on that later. Let's talk about escape velocity. Escape velocity is very important in understanding that the universe cannot expand from a singularity. Escape velocity is the minimum velocity needed for any object to escape a relative gravity well. I have two explanations of how escape velocity works because it's very important. So say you pick up a stone or a baseball and you throw it up in the air. That baseball is going to travel upwards because of the force you put on it, and immediately after it leaves your hand, it's going to start slowing down because gravity is pulling on it, and eventually it will stop and fall back to the ground. Now, if you sling it out even higher or even harder, put more energy into it, it's going to travel a higher trajectory because there's more energy, and it'll take longer for gravity to slow it down, but eventually it'll come back down to the Earth. So if we were to launch a rocket from Earth, from the surface, and it accelerates to any velocity under 25,000 miles an hour, roughly, eventually Earth's gravity will slow it down and pull it back to the Earth. Let's look at one more visual explanation of escape velocity. Go ahead. This thing will play right off the bat. There it goes. So this is an animation I threw together. As this rocket flies, watch the blue arc. The arc represents its trajectory. This quick SLS mock-up, if you don't know what trajectory is, it's the path given to an object by direction and force. So watch this little arc. You'll see as the thing accelerates, the arc or the trajectory gets higher and higher through the atmosphere. As we shut off the engines, it will follow that current path that is left there. You'll see an example of that shortly. Just keeps climbing, it keeps climbing. Now it's going to follow the path because we shut off the engines, and just for this example, it's going to enter the Earth's atmosphere on a ballistics trajectory and completely explode and destroy the rocket, just for fun. Okay, now one more animation. Nope, that's not it. There we go. Is it going? Yep, there it goes. Again, watch the blue line. The faster we accelerate, the further our velocity will carry us. And gravity will continue to pull back on you until you reach a certain velocity. I'm going to speed this animation up because I don't want you to sit here for 8 to 10 minutes and watch this thing accelerate. Ditch the booster, continue with the second stage. Continue to watch that same arc. It's going to change momentarily. You'll see this gray line. This is just representing the orbit of the moon around the Earth. Shortly after we pass it, you will see the arc no longer return down to Earth. It will represent escape velocity. And then you'll see the little satellite symbol as it carries out and leaves Earth's gravitational field altogether. You see that right there? It changed. Watch this little satellite thing right there. It is not going to return to the Earth. It is now going to be in a stationary orbit around the sun. Okay, Joseph, you can switch it back, brother. This is a basic explanation of what escape velocity is. Oh, there we go. There it goes. Okay, this is straight off NASA's website. Escape velocity of the Earth is roughly 25,000 miles an hour. The escape velocity of the moon is roughly 5,300 miles an hour. By the way, ever wonder why there's a face in the moon? It's hard to see from a zoomed in photo, but if you look at the moon with your own eyes, some say they see a face. I believe it's to remind mankind that someone is looking out for them. To me, it looks like a face with breath coming out of its mouth, like the spoken word of God. It even has a third eye, which is your mind. Here's the escape velocity of Mars, roughly 11,200 miles an hour. Getting even larger, here's the escape velocity of Jupiter, roughly 133,000 miles an hour. Here's the escape velocity of our sun, roughly 1.4 million miles an hour. That is a lot of energy. But if you reach that velocity, your craft will leave our solar system entirely. These examples show that escape velocity is based on the overall mass of the planetary body. So what is the escape velocity of the singularity? No one knows for sure, but we can make a good educated guess. Escape velocity alone shows that the universe cannot expand from a singularity. Here's why. The current estimate for the number of stars in the observable universe is around 200 trillion galaxies, each containing roughly 100 billion to 400 billion stars, leading to the total estimate of around 200 billion trillion stars, according to the Little Passports and World Atlas. I asked Google, what is the estimate of the total number of stars in the universe? Let's estimate. Let's estimate it. The escape velocity will tell us a pretty good accuracy of overall mass of the planetary body. Yeah, ignore that. So 200 billion trillion stars, that's a 2 with 23 zeros out of it, after it. Using our star as a reference, because there are some larger and there are some smaller, it seemed like a good happy medium. If we take the escape velocity of our sun, multiply it by 2 and add 23 zeros, we get that really big number in yellow. I couldn't find the name of a number with that many zeros. This number gives us the estimated velocity in miles per hour needed to escape a singularity containing all of the estimated stars in our galaxy. That's just the estimated stars. That does not include planets, moons, asteroids, comets, or other celestial objects with mass. If you include that, you would have a much larger number. Did I mention that the universe has a maximum velocity of about 670 million miles an hour? That's the speed of light in a vacuum. So if you took that really big number and divide it by the speed of light in a vacuum, you get that other number. What is it? Roughly 412 I can't even talk right now. Yeah, thank you. 412 quintillion times faster than the speed of light to escape the singularity. That is moving. If the maximum velocity of the universe is the speed of light, and the velocity needed to expand from a gravity well that is 412 quintillion times greater than that, then that means the universe cannot expand from a singularity. The Big Bang Theory is not possible. I've heard many arguments when discussing this topic. The same physics major that I talked to earlier told me that the James Webb Telescope just discovered a region in space where the laws of physics were different. My response, The laws of physics don't change just because they're inconvenient for your theory. Another argument was it was space that exploded. Well, space would still be pulled inwards by gravity. And then I heard this one too. The speed of light was faster at the beginning, so the laws of physics were different in the first moments of the universe, just so the theory would make sense. Doesn't make any sense to me. Gravity didn't exist until after the universe expanded. So matter didn't exist either until the universe expanded itself into existence. Okay, I'm sorry. The universe cannot expand from a singularity. So here's another model showing the accelerated expansion of the universe. It says that dark energy accelerated the expansion. So it exploded faster than the universe would allow, and then it accelerated even faster. Yeah, I'm sorry, that one doesn't work either. The gravity generated by the singularity contained all the matter in the universe would be too strong for it to expand from itself. Psalms 19:1 says, "The heavens declare the glory of God, and the firmament showeth his handiwork." The only way the universe can exist is if something put it into place and into motion at the same time. The universe cannot create itself. The universe cannot put itself into motion. This next section is called "The Universe is in Motion." This part alone, I believe, is the best evidence to show that the universe requires something to put it into existence.